So welcome to our video on 3.3 example problems. This type of problem here says find all solutions for the equation sine of theta is equal to 0. So this keyword here, all, indicates that we're looking for coterminal angles, meaning we just don't want one solution between 0 and 2 pi. We want to indicate that there are infinitely many solutions to this equation. So let's take a look at where the sine is 0 on the axis here. All right, so let's draw a circle here. All right, so here the sine is 0 and here the sine is 0. So when we say sine is 0, we mean the y coordinate is 0 on the unit circle. So here we've got x is 1, y is 0, and here we have x is -1 and y is 0. So in both of these cases here, your sine is 0. All right, so now let's list out the angles where that occurs. So remember, theta goes positive in this direction here. All right, so we'll just make a list of all the thetas that satisfy this condition. Their sine is equal to 0. So theta could be 0 degrees. All right, and then if we keep going in this direction, could be pi, I should say radians, 0 radians, pi radians. And then if we keep going around, we'll then hit 2 pi. And then if we go around another time, we'll hit 3 pi. And so you can see a pattern developing here. We've got 1, 2, 3, and we're going to keep on going to infinity, all right, in that direction. Now, remember that you could also be going in the negative direction. So you technically are going to have either the plus or the minus of all of these values of theta, and these are going to be coterminal angles. So let's not make this too messy. Let's just say we know that it can be plus or minus, and let's just write it with a plus for illustration purposes. Okay, so we'll write it like that. Now let's just look at this a little more deeply. This is equal to 0, 0 plus 1 pi, and then we've got 0 plus 2 pi, 0 plus 3 pi, and on and on and on forever. Okay, so if we look at the way this is written, we can say that theta is equal to any general case of 0 plus some number, some integer k, times pi. And we don't have to write that 0 there. We can say that it's equal to k times pi, or you could even say it's equal to pi times k, either way. And what we mean by k is that k is equal to 1, 2, 3, etc., 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 but we've already said plus or minus, so k is any integer value. All right, k is any integer. All right, let's try another one of these general forms. All right, let's try this one. This time we're going to find all solutions of sine theta is equal to -1. And this word all, again, is telling you we want all of the coterminal angles, all of the angles that have this sign. Well, sine equal to -1 occurs down here at 3 pi over 2 radians. And in order to hit that point again, I'm going to have to go full circle, either the positive direction or this is positive, or the negative direction. All right, so let's just write our positives here, just so we don't get too messed up. All right, so that means theta is going to start with the base value 3 pi over 2, and then we're going to go 3 pi over 2 plus 2 pi, 3 pi over 2 plus 4 pi, and on and on and on. So each time we're adding a multiple of 2 pi to our base value of 3 pi over 2. So I'm going to say all of my angles, all of my solutions consist of 3 pi over 2 plus multiples of 2 pi. Or you could write that as 3 pi over 2 plus 2 pi k, where k is any integer. All right, plus or minus. All right, so that's our solution for this one. Let's put a box. Okay, in this example, we're finding all solutions of this equation. The cosine of theta is equal to 0. We're looking for all thetas where the cosine is equal to 0. So the cosine is equal to 0 here and here. So this is your angle pi over 2, and this is your angle 3 pi over 2. So let's start out with our base angle of pi over 2, our smallest angle, in other words. All right, in order to get to 3 pi over 2, though, I'm not adding 2 pi, I'm only adding pi. All right, so my next angle is pi over 2 plus pi. And then our next angle, I'm going to add pi again, except this time I've added 2 pi to my base angle. And then I'm going to add another pi to that to get back to this one again. So that's going to be pi over 2 plus 3 pi. So I'm adding multiples of pi each time I go around. So I've got pi over 2 plus 1 pi, then plus 2 pi, then plus 3 pi, then plus 4 pi. So you can see this is going to go on in this fashion. So I can write my general form of the solution. I can say theta is equal to my base angle pi over 2 plus all multiples of k pi, where k is any integer. So that's pi over 2 plus 1 pi plus 2 pi plus 3 pi plus 4 pi, and on and on and on forever. So this is the way we would write our solution for that. Let's try another one. So in this one, we're trying to find all solutions for sine of theta is equal to 1. So sine of theta is equal to 1 right here. So we've got one place here, the base angle of pi over 2. So I'll have theta is equal to pi over 2. But I've got to go all the way around by 2 pi to hit that again. Right? So each of these is going to be a multiple of 2 pi that we have to go around to hit that angle again, etc. So I can write that in the general sense by saying theta is equal to my base angle plus all multiples of 2 pi this time, where k is an integer. And this would be how I'd write my solution. All right, so this one says find all solutions where cosine of theta is equal to 1. So that's over here, and there's only one angle. So we can see again that we're going to have multiples of 2 pi by the time we get back to that angle. All right, so we got to go full circle to get back to that angle to get coterminal angles. So we're going to say theta is equal to 0. This is 0 radians right here. 0 radians plus all multiples of 2 pi. That can be written as without the 0. So we can say 2 pi times k, where k is an integer. More correctly, any integer. Okay, and this is the last one of this type of example. I'm looking for all solutions for the cosine of theta is equal to -1, so that would be right here. It's only one point between 0 and 2 pi, so that means I got to go full circle in either direction to wind up back on that point, coterminal angles. So let's write that as theta is equal to my base angle, which would be pi, plus multiples of 2 pi again, where k is an integer, any integer. And that's how we would write it. All right.